In order to graph in standard form, you need to know a couple of formulas. The first formula that's really important is to find the x-coordinate in the vertex. It's the negative b over 2a formula. So if I go to my equation over here, the invisible 1 out in front is going to be a, the negative 10 is b, and the 28 is c. And if I go substitute those numbers into my formula, I have the opposite of b, which is going to be positive 10, over 2 times a, which is 1. Always multiply the denominator first. 10 divided by 2 is 5. To find the y value, I'm going to substitute 5 into the equation. If you'd like to use your calculator on this one, you can. 25 squared minus 50, 25 minus 50 is negative 25, plus 28 is going to give me 3. So I have a vertex at 5, 3. I like to go plot this. And I like to use the pattern we discussed in class. The pattern is when we square 1, we get 1. When we square 2, we get 4. When we square 3, we get 9. And if you remember, the leading coefficient was 1, so our pattern is not affected at all by the leading coefficient. I can go from my vertex and go out 1, up 1 on both sides. I can go out 2 spaces and up 4 spaces on both sides. And going back to the vertex, I can also go out 3 spaces, 6, 7. I'm going to run out of space to go out 9, so that's okay. I can connect the 5 points that I have to graph the parabola. So we already identified the vertex. I'd like to go back and identify the y-intercept, and the problem is that if you look at this graph, it doesn't cross the y-axis before we get to the top of the graph paper, so I have to figure it out another way. We know in a y-intercept x is equal to 0, and we've talked a lot about how if I substitute 0 for x, the number that I'm going to be left with is the constant at the end. So the 28 is my y-intercept. It makes sense because it's off the graph. It's a positive 28 up at the top somewhere. I can also say that there is a minimum point on this graph because the vertex is at the bottom, and that the minimum value this graph is ever going to reach is 3. I can say the axis of symmetry is a vertical line. And vertical lines are always written with the equation x equals. It goes through the vertex, and the x-coordinate of the vertex is at 5. And the last thing about this graph are the x-intercepts. And in this case, there are not any x-intercepts because the graph does not cross the x-axis. What that tells me is that my solutions to this equation are going to be imaginary, and that because they're imaginary, I will have to find them by using the quadratic formula. So I can come back here and say the opposite of b is 10, plus or minus the square root. I can do negative 10 in parentheses squared, or I can do that in my head. 100 minus 4 times 1 times 28, all over 2 times 1. When I evaluate underneath the square root, I get negative 12. Negative 12 is not a perfect square, but I can divide it by a perfect square, so I'm going to split it into negative 4 and 3. The square root of negative 4 is 2i. And I can simplify this farther because I'm going to divide each part, write it in the form a plus bi, which is a complex number. 10 divided by 2 is 5. 2 divided by 2 is 1, so I'm going to put an invisible 1 in front of the I, square root of 3. My solutions go in brackets.